All right. Hello, everyone. Myself, Roshan, run the show for Bagandai Tech, and meet my colleague Aman. He's architect with Bagandai Tech. We will be presenting today about secure AI integration with Zero Trust and MCP. Let me put you some contrast in terms of AI and what is happening and adding another layer. How many of you have tried to add maybe ChatGPT, another AI agentic platform to your everyday work life? Maybe try to integrate with Gmail or other stuff, right? And then how many of you have faced challenges when it's integrate and to get the right results, right? Think about this in terms of enterprise applications. It becomes even more complex. Given in the real world scenario, we see a lot of data mishap, a lot of data being crossing like HIPAA compliance and all that. So in that context, we are trying to put a framework which will help you guys kind of take it further with the enterprise AI and with help of middle layer like MuleSoft and so on. So here is today's agenda. We're talking about AI-driven architecture shift, which have taken in last, I'll say, 6 months, 8 months time, right? And then about the guardrails around it, what guardrails can be put, which can help us kind of deliver enterprise level of architecture, be it in terms of healthcare. Some of the use cases we will talking up later. And then about the core problem about AI integration, implementation approach, real world scenarios we will have from healthcare, fintech, and from another energy sector. And then key takeaways. Over to you, Aman.
Thanks, Roshan. So let's talk about how AI is transforming enterprise architectures. So traditionally, enterprise systems are built on deterministic workflows. That means a user interacts with the application, and then application calls the APIs. So everything happens in a very predefined and a controlled sequence. That means we decide every step. We control all the executions, and nothing happens until and unless we explicitly define it. So, and now with AI, that model shifts. And with AI, now user interacts with AI, and AI performs the actions. So here, AI basically interprets the intent, and then AI decides what needs to be done. And it works as an uncontrolled manner. So also it performs the execution as dynamically, right? Also, after this AI shift, the orchestration layer is no longer static. It has become a runtime driven and context aware. With this, we have definitely increased the flexibility, but we have reduced the control. That's where the real challenges are.
Okay.
So, if we talk about the risk in AI-driven system, when AI interacts with enterprise system, what can happen? So it can access sensitive Salesforce data. It can query financial data via MuleSoft. It can trigger cross-system workflows. It can also retrieve confidential records. But here is the problem. AI is undeterministic. That means for the same input, there could be multiple different outcomes. That is the unpredictable behavior that AI has, which can lead to the threats like prompt injection, unauthorized API access, data leakage, and privilege escalation. So the challenge here is not limited to integration. Now we have a system that runs in an uncontrolled manner and executes actions dynamically with system access. Let's also understand the core problem with AI integrations. So with a simple example, if you can say, So here is the example. So user asks about show premium complaints. What should ideally happen? It should get the filtered complaints data. But what might happen with the inclusion of AI? It can fetch full customer data, some sensitive information, PII informations. And that happens because it has direct API access via MuleSoft. We have a limited control over its action. We have potential overexposure of data, which then impacts what it leads to. Basically, so now, even in this simple request, what it can lead to overfetching of data, unintended API calls, and data exposure risk. So how we are going to deal with it? For that, we have introduced Model Context Protocol. This is basically a control layer. You can also think it as a policy enforcement layer. What it does exactly? So earlier, when AI used to directly communicate with, directly calls the API, with the inclusion of model MCP, what it does, it calls the exposed tools of MCP. So what these tools does exactly? It defines what AI should do, how it should do, and also it validates every request before its execution. Let's also talk about what is the difference between having the AI integration without MCP and with MCP. So without MCP, there should be a direct AI access via MuleSoft. There would be no control over AI action. There could be a risk of data exposure, limited validation and governance. And however, with MCP, AI uses control tools, defined and restricted actions, secure and validated API access, fully governed and auditable. That is a shift from an uncontrolled AI integration to the controlled one and the secured one. Now let's talk about the end-to-end secure AI architecture. So now, there is a user interacts with the AI assistant, and we have LLM, and then we have MCP server, and then we have MuleSoft Experience API, MuleSoft Process API, MuleSoft System API, and then external system. So let's break it down one by one. Here, user interacts with first AI layer, which consists of this AI assistants, LLM. What it does exactly? It understands the intent, it generates the context. And then after the AI layer, we have MCP layer. What it does? There is a tool selection, there is an input validation, and the access control. After that, it comes MuleSoft layer, where there is the API routing, OAuth authentication, rate limiting validation, data masking, compliance rules, etc. So as we can see, the security in AI integration is not a one checkpoint. It's a implementation across the flow, end to end, before reaching to the external system. So as we have seen, this whole architecture is a zero trust architecture. So in case of zero trust AI systems, there is a say, never test, always verify, especially for AI. So with this, earlier AI directly interacts with the systems. Now it's like AI interacts with MCP, then MCP interacts with MuleSoft, and then there is a Salesforce. That's the whole architecture. So based on the discussion so far, what could be the AI integration best practices? Let's talk about that. So the key points are: avoid direct AI access to backend systems, use MCP for controlled tool-based access, use MuleSoft to manage and enforce API governance, apply zero trust security principles, and implement validation, masking, monitoring. We have a small, quick demo that I just want to walk through. So here, as you can see, we have already integrated with Cursor. I think most of you might be aware of Cursor. It's a development tool, AI development tool, you may say. So in this quick demo, we are trying to create a mule project that creates an order in NetSuite every time an opportunity gets closed won in Salesforce. So let's have that prompt in the chat section. And what it does exactly, it creates the MuleSoft project structure, if you can see in the left-hand side. And then it defines the credentials for access. It creates all the files. Not only that, based on our prompt, it also creates the whole business logic behind it based on our prompt. So you can see it has created all the business logic, end-to-end credentials, and all the files, required files for this project. And now, as part of secure AI integration, what we are going to do, we are going to deploy this application and make sure it's secure, highly available, and performant. So we'll just give a prompt, and here we go. It will then deploy it to different instances and implement the security as required on this one. So this is the quick demo, like you can see the security, high availability, performance, etc. Now, I would like to request Roshan to elaborate on a few use cases that we have already implemented for a few of our clients. So he'll take on that.
Thanks, Aman. That was great done. So we will be talking about 3 use cases here, one in energy segment, one in finance, and one in healthcare. So let's take a scenario in a real world, like from energy sector, where AI, like companies trying to kind of figure out some kind of AI algorithms, and it will pick up the data from like great performance data, weather pattern, or historical failure trends. Well, there's a high risk. So think about this question: what areas are the high risk outage in next 24 hours? You're trying to pick up this from the data which is there with the AI. Well, in the current scenario, if we have access to all the tools directly with AI, what can happen is it can manipulate the data, it can trigger incorrect action, it can bring up the wrong data set. Well, what just Aman suggested right now, in that framework, we'll add a MCP tool, MCP layer to it. When everything will pass through that framework, and then it'll go to MuleSoft, will keep coming back and forth. Now with AI, MCP tool, MuleSoft, and systems, it will work in a way that will allow parameters and define the data structure to pass through it that will give us right results. Let's go to the next slide. All right, so next one is around in healthcare. So when we talk about, let's figure out one doctor is trying to figure out something with AI, with the help of AI, where is generating summaries and care recommendation for a patient. Well, the scenario is give me a summary of this patient condition and recommend care plan. Now what AI really needs is patient history, lab reports, and some medication and treatment records. What can go wrong in this scenario? Well, it can access a lot of information from HIPAA compliance, from GDPR, and so on, which can be PHI data and a lot more. So it's very important to put some guardrail and a framework which can help doctor access summaries, but again safeguard the data and other priorities in place. This framework we have put together, it will help one figure out like the patient to get the right results based on roles or based on like field level restriction and in different capability with help of MuleSoft, which apply for data masking or for compliance policies, and it'll help out everyone. All right, the last case which we want to talk about is an AI fraud claim or like AI-assisted claim processing. In the world of insurance, where we have in mortgage, we have in all the segments, we have a lot of insurance running. In order to give a score for any patient, for any insurance, the AI needs to access all the data from like policy. Is it eligible? Did it do a claim process or not? Payment history and fraud claim others. However, if this data is not available in one place in right architecture, it can lead to give recommendation which might not work for a service agent. So putting this MCP framework is pretty important there so that the data will also not lose. At the same time, it will help allow operation to work efficiently and engage with everyone. So that's about fraud claim process. Well, back to Aman with key pointers of the architecture to carry forward.
So let's talk about where are we heading. So what would be the future of the AI architecture? So the key points are, we are heading towards our AI-first enterprise systems, a policy-driven and governed integrations, secure automations at enterprise scale, human plus AI collaboration models. We are not limiting AI, we are just regulating it and controlling it with the help of that collaboration. And now, what should be the key benefits for enterprise architects with this, combining the Zero Trust and MCP? There would be strong and governed AI security, controlled and safe system access. There would be full accountability and auditability. And there would be end-to-end risk protection. And the key takeaways for today is never allow AI to directly access enterprise systems. Always apply zero trust principles to AI agents. Always use MCP to control AI interaction with tools and APIs. Secure architecture will be the foundation of responsible AI adoption. And here we have added some resources related to this secure AI integration. I would love if you guys can have this screenshot and use it further. So that's all about it. Thank you. Thanks everyone for this session. Thanks for joining us and cheering us. Thanks.